Okay, so the last unit for the module will be on amines and amino acid. So amine is another example of functional groups as well, and amino acid will be an example of essential organic compound that is needed in our body. So outline for this unit, first we will see on the introduction, naming, which is nomenclature, and also properties of amine. Then we will look into some of the reaction of amine, okay, only a few examples before proceeding into the introduction and also properties of amino acid, and lastly on to the function of amino acids. So on to amines. So basically and amines are organic compounds that are derived by replacing one or more hydrogen atoms of ammonia with hydrocarbon groups. So this is the structures of ammonia, which is NH3. Okay, the structure has nitrogen with 3 hydrogen attached. Okay, here we have one lone pair. Okay, so you can go back to drawing the VSEPR theory, okay, or Lewis structure, in order to get this compound. So these derivatives of ammonia, okay, in which that one of the hydrogen, okay, 1, 2, and 3, can be replaced with one of the hydrocarbon. That means you can have carbon here, carbon over here, or carbon over here. So at least one of these hydrogen will be replaced with a carbon, okay, CH3 or an ethyl group or whatever. So there are many biologically active compound, okay, which contain an amine group. So example over here, we have a few compound and also enzyme. Like for example, the first one, it is a dopamine, which is a neurotransmitter. Okay, it is available in our neuron system. Okay, so it helps transferring the signals, okay, to neurons. And then we have epinephrine, which is an adrenal hormone. Okay, then here we have an example of L-tryptophan, okay, which is an amino acid. It also contain amino group over here, okay, in which you have NH2 and one of the hydrogen is being replaced with carbon. And then we also have piperazine. So this is basically a drug that is used to treat nematode infection or worms. Okay, normally doctors will prescribe in order to kill worm that is in our intestine. Okay, and then we have nicotinic acid, or also known as niacin, okay, a type of vitamin or vitamin B, one of the many of vitamin B. And then we have pyridoxine, okay, vitamin B6, and then also histamine, okay, another types of compound that is available in our body, which dilates blood vessel. So these are how amines are classified, okay, as like the other functional group. It also can be classified as either primary, secondary, or tertiary amines. Okay, and some may say it also has a quaternary, but the main thing that you have to know is primary, secondary, and tertiary amines, in which that this amine contain either 1, 2, or 3 alkyl or aryl groups attached to it. So primary amines contain 1 CN bonds, okay, and 2 NH2 bonds, okay, 2 NH bond. While secondary, 2 CN bonds and 1 NH bond. in tertiary, it contains 3 CN bonds and no NH bond. Okay, while for quaternary, this compound is no longer neutral. It contains a positive charge. Okay, as you see that on the nitrogen, it contains one lone pair. So that means it will readily form another bond, but due to that bond, it will lose the neutral what they call properties, okay, in which that it will become a positive sign. So it has 4 CN bonds and no NH bond, okay. So here an example, we have primary amine. Okay, primary amine, you have NH2, which is bonded to CH3. So there's one C bonded to N, okay, one C bonded to N, and also two N bonded to hydrogen. Okay, you have two NH over here. And then secondary amine, you have NH, okay, one NH and two CN bond, CN, CN, okay, in which you have CH3, CH3, okay. So this N bond, it can be any alkyl or aryl group. Okay, the simplest is CH3, so it can be longer carbon than that. It can be a longer carbon chain. And then tertiary. So tertiary, all of the nitrogen is bonded to carbon. Okay, 3 CN bond, CN bond, and CN bond, in which that it is considered to be a tertiary amine. So example, let's try to classify these two compounds. So if you look at the first structures, do you think whether it is a primary, secondary, or tertiary amine? What is the classification for the first compound? Anybody want to try? You have N over here, bonded to one hydrogen. And what is this on these two sides? You have one carbon and another carbon. So that would make this compound secondary, primary, or tertiary. What is it? Anybody want to try?
Secondary.
Secondary, right? Because it is bonded to two carbon, okay, and bonded to two carbon. Okay, and then for this nitrogen, you check whether it is bonded to any hydrogen. No hydrogen. So we have one carbon, one carbon. So this is already two carbon. But what about this one? This also corresponds to another carbon that comes from the benzene ring. So this nitrogen is bonded to three other carbons. So it will make it a tertiary amine. Okay, so this one is secondary. This one is tertiary amine. This one, you have N bonded to two hydrogen. Okay, regardless of whatever over here, you only have one carbon bonded to this nitrogen. Okay, that means there's only one. So it will be a primary amine. Okay, it will be considered as a primary amine. And then this is an example for count how many carbon it is bonded to. We have one carbon, two carbon, three carbon. This is also another carbon that comes from the benzene ring, okay, benzene structures. So 4. So 4, as what is stated over here, okay, it is a quaternary amine, okay, in which there is no hydrogen left. And the nitrogen, if you look at the nitrogen, it is already positively charged. Okay, so secondary, tertiary, primary, quaternary example. Okay, then that is on whether it is primary, secondary, or tertiary. So amines are further divided into aliphatic, aromatic, and heterocyclic amine. So what is aliphatic amine? So in which that an amine that has the nitrogen bonded only to alkyl groups, okay, which is R, basically it is an alkyl group, which is simplest can be CH3, or it can be CH2, CH3, or it can be maybe 10 carbons, okay, or maybe 5 carbons. So as long as it is not aromatic or cyclic, so that will be alkyl groups. So then aromatic amine, an amine in which nitrogen is bonded to one or more aryl group. So example of aryl groups will be benzene ring, okay, benzene, and then heterocyclic amine, an amine in which nitrogen is one of the atoms of a ring. So that means the N is part of the ring, okay. So here we have an example of aromatic amine. Okay, this is benzene ring that is attached to an NH2, okay, NH2. So this is considered as primary aromatic amine. Why primary? Because this nitrogen is bonded to just one carbon. We have H2 over here. So it has its own name. Okay, if you go back to the topic of arenes, okay, and its derivative. So you know that when a benzene ring attached with an NH2 or an amino group, it will be called as aniline. Okay, aniline. And then this is a secondary aromatic amine. You have N bonded to only one hydrogen, but two carbon, one carbon and another carbon. So over here, the name will be written as N-methyl aniline. Later we will see on the nomenclature why it is written as N-methyl. Okay, N-methyl aniline. And this is an example of a tertiary aliphatic amine. So you have N hydrogen bonded to one carbon, CH3, CH3. This two is an example of alkyl group. This also will be an alkyl group because it is bonded to CH2. If it is bonded directly to a benzene ring, that will be under aromatic, but this is bonded to CH2 first before there is a benzene ring. Okay, so this is considered as an aliphatic amine, and the name given is benzyl dimethylamine. Okay, benzyl dimethylamine. Benzyl is for this part, we have benzene ring and the CH2, and dimethyl is CH3, CH3. So nomenclature of amines. So some of these amines have common names. Okay, names of alkyl groups in alphabetical order plus amine. So what does it mean is basically you put the name amine at the end. Okay, amine at the end. For example, like this one, it will be written as ethylamine. Why? Because you have CH2, CH3, which is an ethyl group. Okay, it will be written first, ethylamine. While this one, you have, this is primary amine, this is secondary amine, you have NH, while there is two carbon, CH3 on both sides. So the N is still with amine, okay, the name is still with amine, but there is two CH3 group or methyl group. So it will be written as dimethylamine, okay, dimethylamine. And then for tertiary amine, we have nitrogen here bonded to one methyl group, two methyl group, CH3, CH3, and another ethyl group, CH2, CH3. So it will be written according to alphabetical order as ethyl dimethylamine. So this dimethyl denotes to the CH3, okay, and you don't put di in front because the alphabetical order is based on ethyl and methyl, E and M. So E comes first. Okay, di is just to show that there are two methyls bonded to this nitrogen. Okay, here, oh sorry, we name the alkyl groups bonded to nitrogen and then add suffix to the amine. So this is another example, you have N, okay, N bonded to CH3, okay, and then on this side, there is two ethyl group. Okay, you have CH3, CH2, this is an ethyl, so that means when it is already another bracket, and then you have number 2 here, that means this nitrogen is bonded to two ethyl group. So you have methyl and two ethyl, so it will be written as diethyl methyl amine. Okay, diethyl methyl amine. Diethyl because there is two ethyl group, and methyl over here you have CH3 amine. While this one, okay, you have N bonded to hydrogen, okay, and then bonded to another CH3. And on this side, this is carbon. So this will make the structures as a secondary amine. So on this side, okay, you have cyclopentane. Okay, why cyclopentane? It is cyclic and there are 5 carbons. 1, 2, 3, 4, 5. Okay, cyclopentane. But when it becomes a substituents, it will be written as cyclopentyl. Okay, cyclopentyl. And then on this side, you have CH3, which is methyl. So it will be written as cyclopentyl methyl amine. Okay, C before M. Okay, alphabetical order. Cyclopentyl methyl amine. Okay, cyclopentyl is this side, and then methyl is from this CH3. Okay, this one is an aromatic. Okay, example of aromatic amine. It is bonded. Okay, this nitrogen is bonded to two benzene ring. It is bonded to two benzene ring. Just now, if the benzene is directly attached to CH2, it will be known as aniline. But in this case, when there are two, it will be written as diphenylamine. So the word di denotes these two benzene ring, and phenyl is the substituent's name. When benzene becomes substituents, it will be known as phenyl, okay, not benzene. So diphenylamine, okay, diphenylamine. And then when amine as a substituent, so just now, amine is the main functional group that is available in the compound. But what happens when you have other functional group that has higher priority than amine itself? So on a molecule with higher priority functional group, the amine is named as a substituent. So example over here, we have a compound which contain an amine and also C double bond OOH, which is a carboxylic acid. So between these two, the carboxylic acid will take higher priority. So in this case, okay, the name will follow the carboxylic acid, in which you have to count 1, 2, 3, 4. So there are 4 carbons. So from butane, carboxylic acid will become butanoic acid. And then the position of the NH2 will be written as at carbon number 4, because once you have carboxylic acid, the C double bond OOH will be uh, labeled as carbon number 1. Okay, so it will be 1, 2, 3, 4. So this NH2 is bonded to carbon number 4. Hence, okay, once NH2 is a substituent, it will be written as amino. Okay, 4-amino butanoic acid. Okay, this one is another common name, but the one over here, this is the IUPAC name. Okay, so 4-amino butanoic acid. Another example here, when you have uh, alcohol, okay, so you have benzene ring attached to OH, so this will make the structure known as phenol. Okay, straight away the structure is known as phenol, but at the same time, we also have nitrogen that is bonded to a CH3, okay, and to CH3 over here. So in this case, the name will be 2-methyl aminophenol. So why 2? because the numbering in this benzene ring will start at carbon number 1 at this OH. So COH, this carbon will be labeled as carbon number 1. This carbon will be carbon number 2. So methyl amino, because you have methyl bonded to this nitrogen. So methyl aminophenol. Okay, 2 methyl aminophenol. So amino group that is bonded to benzene ring, so they have a specific name in which their parent compound is called as an aniline. You have benzene attached to NH2, so it will be called as aniline. Okay, but once it has structures like this, in which that the nitrogen is bonded to others than hydrogen. In this case, you have carbon and carbon. Okay, carbon and carbon. So this make the structures as a tertiary amine. So the parent name remain, which is an aniline, but we have to denote that on this nitrogen, okay, contain another 2 methyl group. So hence the word dimethyl aniline, but the dimethyl or these 2 methyl are not bonded to the carbon, but it is bonded to the nitrogen. Hence it is written as N, N. So N, N stands for the position of this methyl. Okay, this methyl is bonded to nitrogen, so you have to write N-methyl. But there is another methyl group, so you have to write again N-methyl. Since there are 2 methyl groups, it will be written as N-dimethyl aniline. Okay, N-dimethyl aniline. And this one, okay, this is just normal aniline, but it also has another methyl group, okay, at position carbon number 4, because this will be regarded as carbon number 1, carbon number 2, carbon number 3, and carbon number 4. Okay, so 4-methyl aniline, or it can also be called as para-toluidine. Okay, para, because the position at 1 and 4. So you can also use P over here, P-methyl aniline, okay, instead of 4. But the name toluidine is when you have NH2 and CH3 on the same benzene ring. This is another common name, okay, but you may stick with this one as well, the 4-methyl aniline. Okay, this is just to show, okay, I just want to show what is heterocyclic amines. So heterocyclic amines, when you have the nitrogen, is a part of the uh, cyclic structures, in which that it is not a substituent that is bonded to the carbon, but it is part of the ring. Okay, so here we have an example of a 3-membered ring. Okay, this is carbon and carbon. Okay, the other than the nitrogen itself, it is not written, then it is correspond to carbon. Okay, you have carbon, 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 and carbon. So the first example is an aziridine, then we have pyrrole, and then this one is pyrrolidine, and this is pyridine, and the last example is just 2-methylpyridine. Okay, so this is an example of heterocyclic amines. So the rules of nomenclature, okay, how they are named. So they have to be selected based on the longest carbon chain. Okay, as usual, you have to select the longest carbon chain, and then the E of alkene, okay, will be replaced with amine. Okay, amine. So this is another way in which you can name the uh, compound. Okay, so substituents on nitrogen will have N prefix. So an example over here, we have NH2 on this side bonded to CH2, 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 CH3. So you have to find the carbon that is bonded to the nitrogen. Okay, the longest chain will be 1, 2, 3, 4, 5. So 5. So you have pentane. So that will be uh, bonded the NH2, excuse me. So the NH2, okay, is bonded to this 5 carbon. So from pentane, you change or replace it with amine. So pentanamine, okay, pentanamine. And then the substituents will follow according to which carbon it is situated. So we have 1, 2, 3. This bromine is at carbon number 3. So you may write it as 3-bromopentanamine. Okay, or you may also put the number 1 over here to denote the position of this nitrogen at carbon number 1. Okay, so you can write 1 or you may not write 1. But if the NH2 is at position other than 1, maybe at second carbon or third or fourth, then you have to write the position of the numbers. And then for the second structures, all right, so this nitrogen, okay, you have to count on which carbon it is directly bonded in which the longest chain. So this is tertiary. You have CH3, two CH3 bonded to this nitrogen, while for this one you have 1, 2, 3, 4, 5, 6. So 6 carbon. This make it the longest compared to this methyl group. So from hexane, it will be known as hexanamine. Okay, hexane to hexanamine. But then we see that the nitrogen is bonded not to the first carbon, but at the third carbon. So you have to write 3-hexanamine. And then what else is there is you have this CH3, okay, 2 methyl group bonded directly to the nitrogen. Okay, so that means once you have another 2 methyl group, it will be written as dimethyl. Okay, dimethyl 3-hexanamine. But this methyl is bonded to the nitrogen, not to any of the other carbon. Okay, so you cannot write numbers. You cannot write 3,3-dimethyl, because if you write 3,3-dimethyl, it denotes that the methyl group is at carbon number 3, but it is actually at the nitrogen. So you have to write it as NN, dimethyl 3-hexanamine. And you have to write 2N, okay, not just 1N, because there are 2 methyl group. And the N are written in italic, okay, that means it is slightly slanted, okay, in italic. So then we go to the properties of amine. So earlier I've shown the structures of ammonia. So this is ammonia, and this one is tertiary amine of trimethylamine. So if you look at this, so this blue colored thing is what we call as the lone pair. Okay, you have electrons over here. You have two electrons, and the angle between the hydrogen is 107 degrees for ammonia, and trimethylamine 108 degrees. So this diagram over here tells you about the electron distribution. So as you know, in organic compound or in any chemical structures, chemical compound, there will be electrons in it. So the electrons can actually be their position can be calculated, okay, using computer softwares in which that we can try to determine where does the electrons prefer to be. And from theoretical postulation, we know that the nitrogen have one lone pair. Okay, that means you have two electrons over here. And based on this, okay, you see the color. The blue color tells you that there is less electrons available, while the redder it is on this side, so it is highly, there is high electron charge over here. So that comes from this lone pairs. Okay, so the lone pairs give this part the almost orange color. So it means it is rich in electron on this area, okay, which is the area with the lone pair of electrons. But while the others, okay, you have CH3 on this side, so there is no electrons or lone pairs available. All of the electrons are being used inside the bond. So nitrogen is sp3 hybridized. okay, with a lone pair of electrons in an sp3 orbital. So this can be proven by using the Lewis structures, okay, Lewis structures, then we will know that it is an sp3 hybridized. So in terms of boiling point, the boiling points, uh, so here it said that NH is less polar than OH. Okay. NH, which is this one, NH is less polar than OH. So it can still form hydrogen bond, NH, but the hydrogen bond are weaker compared to the one in OH. So OH comes from alcohol. So tertiary amines cannot form hydrogen bond with another tertiary amines, thus having lower boiling point. So primary and secondary amine have higher boiling points compared to tertiary amine, because when we want to determine the boiling point, okay, basically you are going to heat the solution, okay, or the compound itself, the liquid compound. So from liquid, all of that compound will turn into gas phase, right? So if it doesn't have this hydrogen bond among the same molecules, so that means it will be easier for the molecules to change form from liquid to gas. But while primary and secondary amine, they have the tendency or the option to form hydrogen bond with another molecules of the same type. Okay, so if you look here, you have N, H. Okay, this is the lone pairs. So the lone pairs can form hydrogen bond with another hydrogen. But for tertiary, okay, it can only form hydrogen bond, okay, from this lone pair with molecules of water. So that means it is hydrogen bond acceptor only. While for primary and secondary amine, it is both hydrogen bond donor and also hydrogen bond acceptor. So the boiling points will be higher than corresponding alkanes, but lower than the corresponding alcohols. That means if you have an alkane, an alcohol, and also an amine, which have almost the same or similar molecular weight, okay, alcohol will be the one with higher boiling point than amine, and lastly will be alkane. So here an example, boiling points of amines are higher than those of alkanes, but lower than of alcohol. So if you look over here, alkane, so boiling point negative 89 degrees Celsius. So that means at room temperature, it exists as gas already. And here, an amine, okay, negative 6, while alcohol, methanol, the boiling point is 65 degrees Celsius. So look at the difference, very big difference. Alkane, amine, and alcohol. And in terms of solubility and odor, odor is actually the smells of amine. So in terms of solubility, small amines which contain 6 carbons and less, okay, less than 6 carbon, are mainly soluble in water. Okay, because all amines will accept hydrogen bonds from water and alcohol. Okay, they easily form hydrogen bonds with water and alcohol. And branching will increase solubility. So what does it mean by branching? Branching on the carbon chain. Okay, like this one, this is considered just a normal straight chain. But if you have branching, maybe you have ethyl group over here, you have another ethyl group attached to this carbon, and then another ethyl group here. So that will increase solubility as well. So most amine smells like rotting fish. Okay, if I believe all of you have at least know what the smell of fish, right? So it the smells is almost similar. Okay, so like ammonia, amines, so the smell is almost like fishy smell. Okay, fishy smell. And then another properties of amines, which is basic. Okay, so amine are considered as basic or a base. So this is due to the lone pair of electrons on the nitrogen. So if you still remember, on the nitrogen, it contains one lone pair of electrons, which can accept a proton from an acid. So due to this reason, being an proton acceptor, so it makes amines a basic compound. And aqueous solution are basic to litmus. So if you done a litmus test, okay, on amines, then you will get a result showing that it is a basic compound. For example, like the value of pKb for ammonia is 4.74. So alkyl amines are usually stronger base than ammonia. Ammonia is NH3. So once you replace one of the hydrogen with an alkyl group, so it will make the whole compound much stronger base. Okay, so increasing the number of alkyl groups decreases solvation of ions. So secondary and tertiary amines are similar to primary amines in terms of their basicity. So then we will go to some of the example of reactions of amines. So just now the properties. So I just want to share 5 examples of amine. One is as base. That means the amine will act as a base. So it will act as a base. It will react with acid. And then the second one is an alkylation reaction. Third will be reaction with nitrous acid. And number 4 is the conversion into amides. The conversion into amides. And lastly, number 5 will be the Hoffman elimination from quaternary hydroxide. So the first type of reaction, which is as a base. So basically, you just have your amine, okay, reacting with an acid. Here, an example of aniline or aromatic amine reacting with hydrochloric acid. Okay, hydrochloric acid. So you are going to end up with this so-called salt structure known as anilium chloride. Okay, anilium chloride. So the chlorine, the Cl minus from this HCl will form a bond with the nitrogen. That means, okay, it will form a bond with this sort of a bond in which that the H, okay, remember you have lone pair on the nitrogen, it will accept the proton. The proton is basically the H plus. So it will form a bond with this H. So hence you have H plus on this side and also Cl minus. And then this is a secondary amine, okay, diethyl amine. You have two ethyl group attached to this nitrogen. So this is an aliphatic amine reacting with a carboxylic acid, also another type of acid. So this is strong acid, this is weak acid. CH3C double bond OOH. So this is ethanoic acid or acetic acid. So the product form will be diethyl ammonium acetate. Okay, diethyl ammonium acetate in which the N, okay, lone pairs will accept this hydrogen. Okay, this hydrogen. So hence it will become NH2 plus. Okay, comma, and this will be the acetate ion. Then the second reaction will be basically an alkylation. So alkylation reaction. So you have over here the amine itself, okay, in which that you can replace the hydrogen, okay. Here you have RNH2 primary. You can convert it into a secondary, okay, secondary amine by reacting with Rx. So what is Rx? Rx is alkyl halide. Okay, so Rx is alkyl halide. So once you have your secondary, you can convert into tertiary by reacting again with an alkyl halide. So basically, this is reaction of alkyl halide with amine. So the reaction is considered to be a substitution reaction. Okay, so if you further your studies in bachelor, you will get to study this reaction type, which is called a substitution reaction. So it can be further converted the amine up into the quaternary types of amine. Okay, you can have it react with the alkyl halide up to 3 times if your starting material over here is primary. Yeah? Okay, so this is the example in which you have your alkyl halide. So this one is ammonia. So this ammonia, one of the hydrogen will get replaced with the CH3, CH2, 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 which is the R. Okay, so this is Rx. So one of the hydrogen will get replaced with the R group. So you are going to end up with butylamine. Okay, butylamine. And then the third reaction, okay, reaction with nitrous acid. So what is nitrous acid? Nitrous acid, the symbol is HONO, HONO. So when you have an amine reacting with uh, nitrous acid, you are going to end up with different kinds of products. For example, here we have primary amines. You have aliphatic and also aromatic amines. So when you have aromatic amines react with nitrous acid, you are going to end up with this diazonium salt. Okay, this will be the product. But if you have aliphatic amine, then you are going to end up with nitrogen gas plus a mixture of alcohols and alkenes. Okay, mixture of alcohols and alkenes. Secondary amine, okay, secondary aromatic amines. So this actually the bond is over here. You have let me redraw. So the bond is on this side. So N bonded to this carbon, and then you have hydrogen N bonded to hydrogen, and another one N bonded to R. Okay, like this. But one of the is the hydrogen. So when it reacts with nitrous acid, you are going to end up with N-nitrosamine or N-nitrosamine. Okay, slightly different than the diazonium salt. And for tertiary amines, okay, the product will be P. P stands for para, or you may also write for nitroso compound. So it will be this kind of product. Okay, so reaction of nitrous acid will give you different product depending on the types of amine that you use as the starting material. So primary, secondary, tertiary aromatic amines will give you different kinds of products. And then the fourth reaction or the conversion into amide. So this is basically the same reaction that is in carboxylic acid derivative. Okay, you have amide. So amide is basically you have C double bond O and R2. Okay, C double bond O and R2, or it can be HR, for example. And this reaction involve, this is acid chloride. Okay, you go back to your carboxylic acid notes. This will be acid chloride reacting with a primary amine. And the product obtained will be N. So this is N substituted amide with HCl. But for secondary amine, okay, when you react with acid chloride, you are going to end up with NN disubstituted amide. Okay, NN disubstituted amide. While for tertiary, okay, tertiary amine, when you react with acid chloride, there will be no reaction. Okay, only for primary and secondary. In this case, tertiary won't give you any product. So that is the fourth type of reaction. The last one is an example of Hoffman elimination reaction. Okay, Hoffman elimination reaction. So the reaction basically has 3 steps. Okay, the first one is what we call as exhaustive methylation, in which that your amine will be converted into this quaternary salt. So if you still remember, you have N that has 4 bonds, so it will be considered as positively charged. So it is a quaternary salt. Step 2, reaction with silver oxide. So this is Ag. Ag in Latin, if you go to the periodic table, it is silver, okay, or argentum. so silver oxide, in which that your quaternary salt just now will be converted into a quaternary hydroxide, okay, plus AgX or silver halide. Where does this halide come? Comes from, the halide comes from the first step just now. Okay, you have this quaternary salt. And then the last step is heat to eliminate. Okay, what does it eliminate? So it will form an alkene as product, and also what is this? A tertiary amine. Okay, you are going to end up with tertiary amine. So the N will be removed altogether from this what you call the starting material. Okay, so your starting material in this case is a primary amine. You want to remove the nitrogen altogether, so you have to undergo this Hoffman elimination, in which that the product will be an alkene. It has to undergo these three steps. Okay, the first step involves the use of alkyl halide, and then the use of silver oxide. Last step is just by heating. Okay, just by heating. So that is the reaction. Okay, some of the example reaction of amine. And what does amine can be used for? Okay, so these are some of the application for amine. So aromatic amines are mainly used as the starting material for the production of azo dyes. So azo dyes is basically a type of coloring. So coloring to use maybe to dye clothing. Okay, you have maybe a type of cloth in which you want to change it into different types of color. So they may use this so-called azo dyes, which is made out of aromatic amines. Okay, and then many drugs are also designed to interfere with the action of natural amines. And amines are also used in making artificial fibers. And lastly, the aromatic amines are also used in detergent production. Okay, detergent. Okay, that will be all on the amines. Now we will go to the sort of another subtopic. Okay, on amino acid, still under the uh, amine title, but it involves slightly different types of compound. So what is an amino acid? So amino acid are basically the building blocks of proteins. So you know your proteins. So proteins, when it is simplified into the very basic form, it is an amino acid. So let's say if you eat fish, okay, that contain protein, it will get digested, okay, in our body through enzyme like pepsin, for example. In our stomach, there is an enzyme called pepsin. So that protein will be simplified into a peptide form. Okay, peptide is a combination of several amino acid, and then once it becomes this peptide, it will be further simplified into the most basic form, which is amino acid. So an amino acid contain a carboxylic acid group, okay, and also an amino group. So each amino acid contains a different side group, which is the R. So let's see what is the structure of amino acid. So this is the structures of most amino acid, in which you have the amino group, okay, on this side, and also you have the carboxylic acid group. So hence you have the combination of amino and also acid. So amino comes from this, the amine, and carboxylic acid give the acid. So amino group. So this is the side chain of R, in which that each amino acid will have different R group. Okay, so that will make them different. So amino acid are soluble in water. Okay, the reason because it can form hydrogen bond on both carboxylic side and also on the amino acid, on the amino group side. Okay, so it have either high melting points or it may also decompose upon heatings. Okay, they act more like inorganic materials than organic compound, in the sense that, for example, like this one, when it is being introduced into water, so it ionizes, okay, to become this so-called ionized amino acid. So one hydrogen from this OH will be removed, okay, while this nitrogen, it contains a lone pair, it accepts another hydrogen from this H2O. So while their name implies that an amino acid are compounds that contain an amino group and a carboxyl group, COOH, so these groups are actually present as NH3 plus and also COO2 minus respectively, meaning like this, okay, it will exist as ionized amino acid because in our body there will always be water. So it may so instead of being always in this form, okay, it will get ionized into this so-called amino acid structure. So they are classified as either alpha, beta, or gamma. Okay, the amino acid can be classified as either alpha, beta, or gamma. So amino acids according to the carbon that bears the nitrogen. So according to the carbon that bears the nitrogen. For example, over here, for alpha amino acid. So an alpha amino acid that is an intermediate in the biosynthesis of ethylene, and then or ethene. So a beta amino acid is one of the structural unit present in coenzyme A. So coenzyme A is what is available in human. Okay, and gamma amino acid involved in the transmission of nerve impulses. Okay, so these are the example of alpha, beta, and gamma amino acid. They all exist as the ionized form. Okay, you have NH3 plus COO2 minus instead of NH2 and COOH. Okay, so there are thousands of amino acids actually available, but there are about 20. Okay, some books say 20, some say 21, some say 22 of essential amino acid that is needed by the human bodies. Okay, that means our requires these few amino acids, okay, to function well. And I've gone with 21. Okay, these 21 are the most common, can be found in human and also from food sources. Okay, so they are divided into several types. One is what is called as amino acids with electrically charged side chain. If you still remember the R group just now, you have uh, from these structures. Okay, this R group will make the amino acid difference. Okay, so the first is classified as amino acid with electrically charged side chain. So this is the carboxylic acid part, and this is the amino group side. Okay, so whatever that is in between is considered to be the side chain. Okay, so this is the side chain, this is the side chain, this is the side chain. So this one where positive uh, side chains, so there are three. You have arginine, histidine, and lysine. Probably some of you may have heard a few of these amino acid types. Okay, and then for the negative, you have aspartic acid and also glutamic acid. And then for type B is amino acid with polar uncharged side chain. Okay, it is a polar side chain but not charged like the first one, which contain positive or negative. So you have serine, threonine, asparagine, and glutamine. Okay, all having different side chain. Okay, and then you have these so-called special cases. So like cysteine, selenocysteine, glycine, and proline. These are labeled as or simplified. Okay, if you look at the name, you have this one, ARG, HIS, LYS. These are the short name. Okay, later we will see once it become a peptide and a protein, why this is quite important. And then we also have this amino acid with hydrophobic side chain. So hydrophobic side chain, it will make the solubility decreasing. Okay, so you have alanine, valine, isoleucine, leucine, methionine, phenylalanine, tyrosine, and also tryptophan. So all of these side chain are hydrophobic, meaning that it is also considered to be non-polar. Okay, so this concludes the 21 types of essential amino acids. So these amino acid basically form peptides. So when a few amino acid combine together, it will be known or called as peptide. So this peptide basically form through an amide linkage. So an amide is basically C double bond O N. C double bond O N. So that is an amide. So this uh, bond will make these different types of uh, amino acid bond together. For example, like this one, you have glycine and alanine combining together, okay, forming glycyl alanine. Or it may be written as GLY-ALA. So you know that it contains glycine and alanine. So this is sort of like the simplified version. Okay, glycine and alanine bonding a bond. Okay. When two amino acid bond together, it will be known as peptide. So structures of protein. So the primary structures of proteins is the particular sequence of amino acid that form the backbone of a peptide chain or protein. So that means to form a protein, you may need a few chain of peptide. So here you already form one peptide bond, but in reality, the amino acid peptide can be longer. Okay, it may contain maybe more than hundreds of amino acid bonding together through amide linkage. Okay, and then a few of these polypeptide chains will form a bond to form protein. So this is four amino acid bonding together, okay, to form a peptide. So this one contain alanine, leucine, cysteine, and methionine. Okay, methionine. So the nonapeptides of oxytocin. So if you notice, oxytocin is the types of hormone, or maybe some also call it as the happy hormone. Okay, and vasopressin have similar primary structures, differ only in the amino acid at position 3 and position 8. And this is an example for the structures of insulin. So insulin was the first protein to have its primary structure determined. It has a primary structures of two polypeptide. So you have one peptide, another peptide. So when there is two, we call it polypeptide. So these two peptide bond together through disulfide bonds. Okay, so this one contain 1, 2, 3, 4, 5, maybe around 20 amino acid. This one could be maybe up to 30. Okay, this one 30 amino acid. This one I think around 20. So these two chain, okay, of peptide form a bond, forming what you call as insulin. So what is the use of insulin in our body? What is the use of insulin? It's basically try to what you call uh, uh, the word is to digest glucose. Okay, glucose. It is produced in our pancreas. Okay, insulin. So A chain, this one, okay, with 21 amino acid, and B chain with 30 amino acid. 21 and 30. So that is all on the topic of amino acid and also amine. So